Okay. Good evening to everyone. I think you can see the slides now. So yesterday uh, I gave the definition of DNF and CNF. Just I'll recall a formula which is equivalent to a given formula pi, which consists of sum of elementary products is is called DNF or disjunctive normal form. Similarly, product of elementary sums is called CNF or conjunctive normal form. For example, negation P and Q, negation P and negation Q are examples for elementary products. Similarly, we can give P negation P or Q, P or negation Q, or negation P or negation Q are examples for elementary sums. So procedure for to obtain a DNF, they gave here only DNF. Similarly, you can give the procedure for CNF also. So first, we should remove the connectives, these two connectives in the formula by using. Suppose if you have phi implies psi, it should be replaced by negation phi or psi. Phi biconditional psi, you can replace by either this relation or this relation. Again, I will write these conditions, these identities or results in the next slides. So after applying, after removing connectives, you need to apply a distributive law or associative law or commutative law or De Morgan's law, whatever which is needed, and finally we'll try to get a DNF. So this is the result for condition biconditional P biconditional Q is equivalent to P biconditional Q is equivalent to P and Q or negation P and negation Q. And similarly for P biconditional Q, you can use negation P or Q and P or negation Q. The first problem, find conjunctive normal form or CNF of Q or P and R and negation of P or R and Q. So conjunctive normal form means it is what? Product of sums. So okay, the given, I'll write the expression, same expression, Q, R, P and R and negation of PRR and Q, which is equivalent to. So here I am going to apply distributive law. Okay, because R here have and, that's why I am going to apply distributive law. QRP, QRP, and because I need a product of sums. So Q again what? QRR. Okay, and then and apply De Morgan's law. I'll take this negation inside. So then you will get negation of PRR. Instead of R, you have what? And instead of and, you have R or negation Q. Okay. Now you can put a bracket if you want here. So now this is equivalent to. So you can write this is PRQ using commutative law and Q or R, and so apply here De Morgan's law again. So you'll get what? Negation P and negation R, and then here bracket R negation Q, close the bracket. So now again here you can apply what? Distributive law, because this is a P and Q or C. Sorry, okay, A and B or C. So this is equivalent to P or Q and Q or R and negation P or negation Q and negation R or negation Q. So see here, these are all and, okay. This is and, this is also and, here also we have what? And here you can see R, 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 R. So now this is product of sums. So this is the required CNF. Okay, this is product of elementary sum, or this is what? CNF. I'll write here. This is CNF of the given formula. Okay. So second problem, obtain CNF, obtain CNF of negation of P or Q obtain CNF of negation of P or Q by conditional P and Q. So solution. So already I told that there are two equivalent conditions for biconditional P by biconditional Q. So I am going to use the first one, that is P biconditional Q is equivalent to P and Q or negation P and negation Q. So this is the formula I am going to use here. Okay, now consider this is P, this is what? Q. So I'll take negation of P or Q, biconditional Q, P and Q, which is equivalent to, so, okay, which is equivalent to, you should write first P. P is what? Negation of P or Q, and then and Q. Q is what? P and Q. So put a bracket like this. First part is over. R. Next, negation of P. Negation of P means this is P. Negation P means you will get only what? P or Q. Okay. Or you can write negation of P or Q. Close this bracket and close this bracket, and then and negation of Q. This is Q. Negation of P and Q. Close this bracket and close this bracket. Okay. So now this is equivalent to, I'll put here equivalent to, here I'm going to apply De Morgan's. So you'll get negation P and negation Q. Again now and P and Q. P and Q. So everywhere you have and. Okay, now R. So negation of negation. Okay, I'll get what? P or Q. Okay, on this bracket. Here we'll get what? Again this bracket. This bracket is here P or Q. And here apply negation De Morgan's law. So you'll get negation P or negation Q. Okay. So now this is equivalent to, okay, here you can combine what? These two, okay, and also similarly you can combine these two because all of them are same symbol and so P and negation P is false. Similarly, Q and negation Q is what? False. False and false is false. So totally this is false. This is everything is, from this I get only false. Or P or Q and negation P or negation Q. So we know that again, okay, we know that F or P. F or P is what? P. So this is equivalent to P or Q and negation P or negation Q. So again, this is what? Product here. Here this is what? Sum. Product of sum. So this is again CNF. So this is the CNF of the given formula. This is CNF of the given formula. Okay. So now we'll move to the next problem. Third problem. Find the disjunctive normal form or DNF of negation of P or Q by conditional P and Q. The same problem you can see here. Here also, here we found what? CNF. Here we are going to find DNF. So I am going to use the previous result. Okay, there is no need to, okay, just I'll copy this portion. Same idea. Okay, that's why I don't want to waste our time. So P by conditional Q is equivalent to what? The P and Q or negation P and negation Q. Okay, if you apply this result here, the same thing. Up to this you have same thing. The next step is a little bit different. You have, so here you have, so this is equivalent to, I'll write in, okay, I think you have P or Q and I'll write in the next step, which is equivalent to P or Q, P or Q and negation P or negation Q. So now we need sum of products. Okay, that's why this is equivalent to sum of products. I need sum. Okay, so what we can do here. Okay, so sum of products. Okay, so consider this is A, P or Q. Okay, P or Q. Uh, A and negation P, close the bracket. Consider this is what? A, this is A, this is B, this is C. So A and B are A is what? P or Q and C. And C is what? Negation Q. Close this bracket. So this is equivalent to, so again apply distributive law here. P and negation Q or Q and negation P or P and negation Q or Q and negation Q. So which is equivalent to,
Sir, first term P and negation P, sir.
sorry,
First term P and
where,
negation P. First term.
okay,
That
yes,
one.
yes, correct, yes, thank you. Yeah, thank you. P and negation P, yes. So this is actually false, false, or you can write using commutative law negation P and Q, or this is P and negation Q. This is also false. So finally, you will get F for P is P. So negation P and Q. Okay, negation P and Q, or P or negation Q. P or negation Q. So you can see here, this is actually what? Sum. This is what? Product. So it's a sum of product. So that's why this is what? DNF. This is DNF of the given formula. Okay. So next problem. Find. Okay. So before going to solve this problem, uh, first of all, I will tell there is one more. Okay, I think for this we don't need us that formula. Okay, you can do it directly. So find DNF of this formula. So first I will write P and negation of P or bracket, again a bracket, again a bracket, P and Q, or negation or, close this bracket here, and P, close this bracket here. This is equivalent to, here P, DNF means sum of products, so P, okay, and okay, if we apply here De Morgan's law, you'll get what? Negation of P, sorry, this is actually Q here, here I wrote P. So it should be Q. So negation of Q and negation R. Close this bracket. Okay, and then R. Now Here I'll take this is A, this is A, this is B, this is C. So A or B and C apply distributive. So you'll get A and B. That is what P and Q, P and Q and P close the bracket, and then R B and C. B is what negation R and P. So which is equivalent to, okay, which is equivalent to. So again, this is here you can apply. Okay, here everywhere you have and, so that's why you can put what P and negation Q and negation R, or here everywhere and. So you can write P and P is what P. So you'll get finally P and Q. Okay. The reason is P, because you have and, so P and P is P. So that's why you'll get what again P and Q, or P and negation R, or P and negation R. So you can see here this is actually what a sum here, product. This is product. So this is a sum of products, which is a DNF. Which is DNF of a given formula. Okay. So now we'll move to the next problem. Okay. So here obtain DNF of P implies Q and negation Q or negation P. Solution. So first I'll write the formula again here. P implies Q and negation Q or negation P, close the bracket, which is equivalent to, so first P implies Q, everything is Q. So negation P or Q. Q is what? Q is the whole expression. P implies Q and negation of negation Q or negation P, close this bracket, close this bracket. So now this is equivalent to negation P or, so again P implies Q, you can write what? Negation P or Q, close the bracket, and apply De Morgan's law here. The negation of negation will get Q and P, close this bracket. So now this is equivalent to, I need a sum of product, so that's why I'll keep negation P, or I will take sum of products na inge R irukku, inge and irukku, here and irukku. So I need the sum of product. So product is I need inside. So that's why I'll keep this term. This is whole term. C avchikku. C. This is what? A. This is what? B. So A or B and C, you'll get A negation P and C. C is what? Q and P. Close this bracket, close this bracket. And then R B. B is what? Q and P. Close this bracket. So now this is equivalent to negation P or So everywhere you have and, so you can apply commutative law and then associative law. So you will get P and what? Negation P and Q, and then R. Again and, so Q and Q is Q. Okay, or you can write P and Q using commutative law, P and Q. So now this is equivalent to negation P or this is actually false. Okay, false and Q or P and Q. So which is equivalent to negation P. This is actually false because F and Q is F or P and Q. So which is equivalent to negation P or negation P or P and Q. So which is what? Actually, this is sum of product. This here have sum. Okay, this is what? Product. So this itself a product. Okay, so this is in, this is DNF of a given formula. Okay, now for the same problem, I am going to find the CNF. Okay, that is the next problem. So for this, I will use okay, maybe the first two line. Okay, even I will use okay. So now here, okay, this is the given problem. So first line, P implies Q is what? Negation P or Q, and this is equivalent to negation P or P implies Q. Again we'll write what? Negation P or Q, oh, and then and De Morgan's law, Q and P. Okay. So in the last, in the previous column, we'll take this is A, this is B, this is C. But here slightly different way we are going to do. So because here I need CNF. CNF means product of sum. So that's why I'll take this is A, this is B, so this is C. So this is the crucial point. Okay. So initially, students are a little bit difficult to. Uh, so which one we should take A, which one should take B, which one C. Okay. So these types of problems you may face. So if you need to solve more problems, other then only you can get the idea. Suppose if I solve 5 problems in the classroom, means so maybe your faculty maybe solve 5 to 6 problems. You will choose from the book. Okay, from example or exercise, you need to take some problems, and then you need to try. So then only you know the difficulties, and then from the difficulty you can easily overcome. Okay. Now this is Okay, A, that is negation P, or negation P or Q, A or B, and negation P or Q and P. So which is equivalent to, so here everywhere R. So negation P or negation P. Okay, you'll get negation P or Q, and but here R, here you have and. So you should apply uh, distributive law. So negation P or Q and negation P or P. So actually this is what true, which is equivalent to negation P or Q and negation P or Q. I think negation P or Q, negation P or Q is what? Negation P, okay, negation P or Q, there is no need to write again. Because P and P is what? P. And this is actually what? True. So this is what? A negation P or Q. Okay, I'll write in the next slide. This is equal to negation P or Q. So actually, I have only one term here. Okay, wow. So this is product of sum, because here have sum. This is of the form. I will show you. Here I have more terms here. Here product of sums. Even suppose if I have only P or Q, means this is also what? CNF. Even if I have only this term, negation P or negation Q, suppose this term itself what? CNF. Similarly, this term itself CNF. This is product of sum. You have sum here. This is CNF. Okay. So before going, okay, next problem. There is one more problem we will do. Before going to the next problem, I will give one law, extended distributive law. Actually, extended distributive law is P or Q and RRS, which is equivalent to P and R, and then R, P and S, and then R, Q and R, Q and R, and then R, Q and S. So this is what? Extended distributive law. Actually, extended distributive law is if repeated application of distributive law. Okay, I'll give the proof also here. P or Q and R S. So consider this is A, this is B, this is C. So A and that is a P and RRS, P and then R Okay, A and C is over. Then B and C next. Q and RRS. So first time I applied distributed law. If you apply one more time distributed law, you will get extended distributed law. So if you apply two times distributive law, you will get extended distributed law. P and R, P and R, P and S, R, Q and R, R, Q and S. So that's this is extended distributive law. Using this, we will solve one problem. Find DNF of Q, R, P and R, close the bracket, and then and negation of PRR and Q. So here solution. So I'll write the whole expression again. QR, P and R, and negation of PRR and Q, which is equivalent to, okay, here I'll keep this one as it is. So if you expand this one, the problem is here you'll get what product of sum you'll get here, but we need what sum of products. Okay, wow. So that's why I'll keep this one as it is. Q and P and R, and then
QR,
apply
sir.
De Morgan's law. எங்கப்பா
that statement
இங்கயா?
QR அது கீழ சார், அதுக்கு அடுத்த ஸ்டேட்மெண்ட்.
Okay. Okay. Here. Okay. Thank you. So this is Q, R, P and R, and if I apply De Morgan's law, you'll get a negation of PRR, and then here what R negation Q, close the bracket. So now this is of the form. You can see here. This is A. Okay, A. அல்லது P ன்னு வச்சுக்கலாம். Okay, P. This is what Q. This is what R. This is S. So P R Q and R R S. This is look like this extended distributive law. Now you can apply, because here you have what? Here you have, and here you have what? R R. So then you can apply extended distributive law, or you can apply distributive law 2 times. You will get the answer. No problem. This is equivalent to, the only thing is sometimes if you open this one, okay, then you may be struck. Okay, actually I tried in the classroom today. I opened this one, so then it is a little bit difficult to find what DNF. So my suggestion is you should learn this one and then try to give some other proof. Okay, if possible, you need to try for the same problem. Do slightly different method. You can try. So because in the examination, if you try, maybe you will waste your time. So in the free time, you can try. Okay, now Q and this quantity. Okay, Q and there is a P and R. P R is what? Negation of P R R. Close this bracket, and then R, and then again first one and then the last one. P, sorry, Q and negation Q, and then R, and then Q and R. What is Q? P and R, and negation of PRR. Okay, negation of PRR, close bracket, and then R, Q and S. So this is what? P and R, P and R, and then and negation Q. Okay, so which is equivalent to Q and apply De Morgan's law, negation Q and negation R. This is Q and negation Q is false, and then P and R, and apply De Morgan's law here, negation P and negation R, and then R. Everywhere you have and, so P and negation Q and R. So now this is false because Q and negation Q is
Sir,
false.
Q and negation
So
P,
here
sir.
also, yes, negation P. Yes, thank you. So it's not false. So okay, this is negation P. So what you will get, a negation P, first I'll write, and Q and negation R, and then R. Here I missed R, maybe. Yes, R I missed. Because here this is F, this R I missed here. Okay, I'll put it R here. F R P is P, but here also this is also what? Okay, I'll write F R. This is also P and negation P. R and negation R is false. R P and negation Q and R. So finally you will get which is equivalent to negation P and Q negation R. Okay, and then R, P and negation Q and R. So this is actually, here you can see here, this is sum of products. Okay, sum of products. So this is a DNF. This is the record DNF of the given problem. Okay, and then I will going to tell what most important remark, that the conjunctive, the disjunctive, or that is a DNF, CNF of a given formula is not unique. Okay, for example, consider the formula P, R, Q, and R. If you take this one, so this formula itself in sum of, this is sum, this is product. So that is in DNF. Already this is in DNF. So now using distributive law, you can write PRQ and PRR. from here to here distributilla. Next, again I am going to apply extended distributilla from here to here. P and P are where, when you can apply extended distributilla, here you have what, and here you have what, R and R. So P and P are P and R are Q and P are Q and R. So P and P is what, P, R, P and R are, this is what, P and Q are Q and R. Again, this is also what, sum, sum, sum. This is itself a product. This is product. This is product. This is product. So again, this is also what, sum of product. This is also sum of product. That's why DNF and CNF is not unique. But sometimes students may understand wrongly. Sometimes they will try in different method, but somewhere else they done the mistake, and then they will get some expression. So maybe that expression is equivalent to, it's not exactly equivalent. So so my intention is, if it's not unique means you can try in some other method, you can get but the steps should be correct. Okay, each and every step should be correct. One is obtained from the other. So here, this one you can obtain from this one. Similarly, this one you can obtain from this one. So that is the meaning. So I'll stop here. The next class, maybe tomorrow, we will discuss PCNF and PDNF. Okay, thank you. And thank you for your interaction. If you have any doubt, you can ask to me. Whenever I'm doing some mistakes, okay, so okay, some of them are pointing out. So thank you. Uh, Maybe I'll try to take as many classes as possible. Okay, thank you everyone.